the next speaker is Serena Federico, who is also at Ghent University. She is a Marie Curie Fellow. And so she will talk about smoothing and Strichartz estimates for degenerate Schrödinger operators. Please, Serena.
Thank you very much. So in this short presentation, I will mention some recent results about smoothing and Strichartz estimates for degenerate Schrödinger operators. And in particular, I will talk about these two classes of Schrödinger operators. So the first class is denoted by L alpha, and the degeneracy is given by the presence of this coefficient t to the power alpha, while the second class is denoted by LC, and the degeneracy is given by the presence of this coefficient, C prime t, where C prime is the derivative of a function C. So I will start with the first class, and the first class was analyzed by Giulia Staffilani and myself, and we proved some weighted local smoothing estimates, both homogeneous and non-homogeneous, for the solution of the following initial value problem 3. And in particular, let me say that here the very delicate point is given by the presence of this first order term. So when B is identically 0, one can essentially use Fourier analysis methods and find the validity of these estimates. But if B is not identically 0, one has to use the pseudo-differential calculus. And if we do so, we can prove the following general result, which is true both in this case and in this case. So here, I won't go into the details of the theorem, but what is important is to consider this condition given in equation 4. So essentially, in order to prove the smoothing effect, we need to impose some decay conditions on these coefficients Bj, which are those appearing in this part. So if this condition is satisfied, depending on the regularity of the function f, which is the non-homogeneous term here, we can prove these three estimates given in point 1, 2, and 3. And in particular, in point 2, we have a weighted version of the homogeneous smoothing effect. So we have a gain of 1/2 derivative of the solution, of course, weighted here in time. We have a weighted gain of 1/2 derivative of the solution with respect to the regularity of the initial data U0. And in the third point of the theorem, we have the inhomogeneous smoothing effect. So we can see a weighted gain of 1 derivative of the solution with respect to the regularity of the non-homogeneous data F. So by using these estimates, we were able to prove the following local well-posedness results for these two initial value problems. So the first one is a semilinear problem, and we have the following theorem. So if condition 4 is satisfied, then we have local well-posedness for any s bigger than n/2, and it's the space domain 2. And for the second initial value problem, if we have that condition 4 is satisfied, so we have this decay condition for the coefficients Bj, then we have local well-posedness for any s bigger than this quantity, where essentially this constant depends on condition 4. And in particular, we have that the local well-posedness is proved in this weighted space. So here, this function lambda is nothing else, this Japanese bracket to the power minus sigma. So let me show you now the results that we have in for the operators of the form LC. So let me go back. These are the operators, and these operators were studied by Michael Rozhowski and myself. So we considered global smoothing estimates for this operator. So we used comparison principles in order to prove several global smoothing estimates. And here in the poster, you can find the statement of one of these smoothing estimates that we proved. And what is important to understand here is that here we have the degeneracy given by these coefficients. So we allow this coefficient to vanish not only at finitely many points, which is the first point of the theorem. So we have this weighted estimate. But we can also consider the case when the zero set of C prime is countable, and we have another weighted smoothing estimate here. So, of course, here the weight depends on the degeneracy that is on the coefficients in the operator. For the class LC, we also proved Strichartz type estimates, both global and local. Here in the poster, you can find the statement of the local ones. And again, we have weighted estimates because as you can see here, we have the weights depending again on the... And the reason why somehow the local version of these estimates is somehow more important is because it is used in order to prove the local well-posedness of this semi-linear problem. So we were able to prove the following theorem. So if P is this exponent here, and it is in this range, and we consider C, which is C1, it vanishes at 0, and it is either strictly monotone or such that the 0 set of C prime is finite for any finite time, then for any initial data in L2, we can find a time depending on these quantities, such that we have a unique solution which belongs to this space, okay, to this space. And in particular, it depends continuously on the initial data. So I don't have time to go into the details, but if you're interested in a few more details, you can check the poster on the website of the conference. So thank you.
Thank you. So let me say that indeed the post is on the website, and also the paper is on archive, and also there is a special dedicated website for this Marie Curie project by Serena, and